Okay, good morning. We're going to kind of, talk a little bit about leaf structure today. So, more diagrams. Lots of diagrams on this one. First thing we're going to talk about is kind of where the leaf is going to come from. It's going to originate from an apical meristem. So, kind of one of those side little offshoots. If you look at the diagrams I've drawn you, if you look at the far right one, the one that looks like the shoot apical meristem diagrams, you can kind of see the little teeny weeny tiny buds there. That's could be an axial of a leaf in the branch. Actually, I've drawn that incorrectly. So I just noticed that the branch is actually pointing to the wrong thing. But it's where that branch is going to start. That's going to be where the meristem is going to create that leaf from. So there are two parts that you need to be aware of. It's called a leaf trace and a leaf gap. If you look at the far left picture that I've drawn you, it's like if I took a cross section. I took a cross section of a branch or something, or a stem rather. This is kind of what you would see. I didn't label it, but that inside C-looking area is going to be your vascular tissue. And then the trace is going to be the beginnings of the offshoot for the leaf, or this, what we might call collectively the stem of the leaf. And then the space in between that it leaves is called the leaf gap. The middle diagram shows you the view from the side. So it kind of makes a little more sense there, I think. So there's actually a break in the vascular tissue. And then the picture that I've drawn that looks like the shoot apical meristem really kind of shows you where everything is in relation to the shoot apical meristem, so you can kind of see all the different branches popping off. So your cells for storage. Generally, these exhibit determinate growth. So there's it's going to grow and then it's going to stop at some point. Usually when it reaches a certain shape. So leaves will exhibit determinate growth. Okay. We got to divide it into monocots and dicots again because they are structurally different. We're going to talk about dicots first. They have a blade, which is called a lamina. And I've drawn that for you on that middle set of diagrams. You can have a petiole or a stalk, what we would call like a stem of a leaf. Or it can be directly attached to the stem, in which point we would call it sessile. You may or may not have, with a petiole, you may not have stipules, which are little flat-like appendages that form at the base, closest to the stem. With a monocot, it's going to just have a blade. It's not going to have a stalk. What it actually forms is called a sheath, where it wraps around the stem. Monocots are going to have intercalary meristems. And these intercalary meristems allow for indeterminate growth, so they keep growing forever, which is why grass keeps growing and never stops growing until it goes into dormancy. However, your leaves on your trees don't just keep growing all summer long. You know, they get to be a certain size and they stop growing. So monocots exhibit indeterminate growth. Dicots are going to usually produce or show indeterminate growth. By the way, it's kind of random. I should go back to this really quick, but your petiole or your stalk, oftentimes that is going to be made up of collincomous cells for that extra supported structure. Just kind of a random fact. Okay. There are a couple of things that all leaves are going to have, no matter if they are monocot or dicot. They're all going to have the epidermis. They're all going to have mesophyll. Mesophyll is a tissue that's made up of parenchyma cells that have chloroplasts. There are different types of mesophyll. But you're really only going to see the two different types in dicots. And they're based on their shapes. And then they're all going to have vascular bundles of xylem and phloem. So, here's where the fun drawings come into play. So, depending on where the plant is residing, that's going to determine what kind of leaf structure it's going to have. Mesophytic plants are going to reside in, I'm going to say temperate areas. Not too dry, not too wet. So they're not going to have lots of these little bits and pieces that are going to be needed for extra support or things in place to preserve water. They're kind of what I might call a normal leaf, maybe. Quote unquote regular leaf. So if you look at your diagram there at the bottom, the typical mesophytic dicot leaf, you're going to have your epidermis on either side. The top layer of all of them is going to be called the adaxial epidermis. The bottom epidermis of the bottom side of the leaf is going to be called the abaxial epidermis. On these guys, you're only going to have a cuticle on top. They don't really need a cuticle on the bottom. Now, here's what I was talking about, the different types of mesophyll. Dicots are going to have two different types. They're going to have palisade mesophyll and spongy mesophyll. So, you can see in that one, both of these types have chloroplasts. I don't know how well it copied, but there should be dots there to denote the chloroplasts. And then you've got your vascular bundle there in the middle. But it's interesting to note that the primary xylem and phloem in the leaf meet directly. There is no undifferentiated procambium. Surrounding your vascular bundle is a mass of parenchyma cells that we're going to call your bundle sheath. And then off of that, in certain areas, there will be bundle sheaths sometimes. Bundle sheath extensions, I'm sorry. Sometimes they're there, sometimes they're not. Guard cells are going to be on the bottom side of the leaf, and that's to preserve water vapor from escaping, because if you think about it, which side of the leaf is probably going to see more sunlight? The top part. So you don't want to be opening those guard cells to take in water on the top side where it's going to potentially lose water vapor because of the sun. So it's going to be on the bottom side where they don't get direct sunlight in order to hopefully preserve some of that water. The last thing I want you to note on here is that the intercellular spaces between the mesophyll, they can have trichomes on those. So, okay, moving on. Hydrophytic leaf of your dicot. These particular plants are going to grow where you're either totally or partially submerged in water. So, the only major difference between these is the arrangement of that spongy mesophyll. They form those boxes there. And then if you notice, they've got osteosclerids in there, in some of that empty extra space there. They're made, if you remember, sclerids are made of are a specific type of sclerenchyma cells, so they're going to be there for support. Okay, so that's pretty much the only major difference there between that and the mesophytic leaf. Your xerophytic leaf, dicot leaf. Xerophytic leaves are going to be on plants where they are growing in particularly dry environments. So these guys really have to be careful about their water vapor intake and their water conservation. They're going to have a really, really thick cuticle to try to help prevent some of that water vapor loss. And they're going to have a pretty thick adaxial epidermis as well, several layers long. And then the interesting thing to note is on their abaxial epidermis, it's going to have sunken stomata. They're where their guard cells are, and again, their guard cells are located on the bottom. Oh, hydrophytic leaf, it's on the top because it doesn't matter. They're partially or totally submerged in water, so they don't need to worry about water intake. Xerophytic plants living in deserts, they absolutely need to, so they're definitely going to be on the bottom. And they've got a cuticle, if you notice, on the top and the bottom of their leaf. The xerophytic leaves can also have the trichomes as well. So I did not label that one on mine, but I'll go ahead and label it now and label it on yours. The vascular bundle being xylem on top, phloem on bottom. So your monocot leaf, I don't have any notes for that other than the diagram there. Oh, one more thing, sorry, before we move on. One more thing about your xerophytic leaves. Sorry. The water vapor is going to end up leaving your guard cells on the bottom side. Again, it's on the bottom to minimize water loss. It's going to get caught on those trichomes. That's why those trichomes are there. And so that kind of slows down the rate of diffusion by it getting caught on those trichomes there. Since they become, so the water vapor kind of settles in on that trichome, and so it's just going to kind of slow them down a little bit. Okay, your monocot leaf looks way different, I think. You don't have the spongy and palisade mesophyll. You just have one type. So you still have your cuticle on the top. Monocots are going to have guard cells on both sides of the epidermis. So you've got your vascular bundles. You've got your bundle sheath going around it. Then you have your mesophyll going around that. I drew an X on the bundle sheath. It's that inner layer of circles. Just like with the mesophytic dicot, you may have a bundle sheath extension in a monocot. You might not, but you might. So this kind of gets you through the basic leaf structure. We're going to do leaf orientation. I'm going to call it leaf orientation tomorrow, and some leaf modifications. Some of the modifications you've heard of, so some of them you haven't. Oh. I don't know if it's been screen sharing or not, or if you've just been staring at the ceiling. So I'll share this with you just to be safe, so that way if you need it, you'll be able to see the notes. So if you do have any questions, just let me know.